In this video tutorial, we are going to just talk about how to measure some of the components within our circuit, some of the variables within our circuit for more complex circuits. So here's what's known as a complex circuit. Okay, it's not a simple circuit because I have more than one light bulb being connected in different arrangements. So you'll see here on the left side, I have my 3 battery sources and I have 4 bulbs connected. I have 3 bulbs that are connected kind of in one loop here, but then I have this second bulb, or I should say a 4th bulb that's branched off here on the second. So let's say that I want to measure some of the things like voltage, current, resistance within the circuit. Understand that some of the things are given to you. For example, we know the voltages of the batteries are given. The resistance of each bulb is given. We can modify these by clicking on each individual component, and obviously we could change the voltage. We could change the resistance of those individual items. But now let's say I want to go throughout the circuit and measure some of these things. So for example, let's say I want to use my multimeter to measure the voltage across these different components. Understand that voltage represents the energy within a circuit, that the voltage of the battery is representing the energy supplied by the battery to the charge to make it move. And then we look at the light bulbs and such, we can measure voltage, which is going to represent the amount of energy being utilized by those different components. So when I want to use my multimeter or my voltmeter, again, remember there's a black lead and a red lead. Okay, this is going to measure the voltage across a component, which means that we have to place the black lead on one end of our component and the red lead on the other end. The black lead's always attached to the negative part of that component, and the red lead's always attached to the positive, and that's all related to the battery. So let's say I want to measure the voltage across all 3 batteries. I would take the black lead and connect it to the black terminal, or the negative terminal of the battery, and the red lead I'm going to connect all the way to the top. Now, since I'm using 3 batteries, I want to measure the voltage across all 3. Notice here it would give me 27 volts. 27 volts would represent the voltage supplied by those 3 batteries to all the charge within the circuit. So now let's say I want to measure the voltage across the different components, such as the bulb. So let's say I want to measure the voltage across this bulb up here. Well, again, the bulb has 2 endpoints, just like a battery. So what I need to do is place my 2 leads at those 2 endpoints. What I want to make sure that I do is that I always want to connect. So here's one endpoint, here's my other endpoint. I want to connect the red lead always to the one that's connected to the positive terminal of the battery. So you'll notice here, here's my positive terminal of the battery. If I follow the wires, this terminal right here is connected to the positive terminal of my battery. And therefore this, if I follow it all the way through my circuit, would end up connecting to the negative. So I would place my other lead over here. And notice it'll give me my voltage here of 10.80 volts. So if I want to measure the voltage across any component, I just got to think about where my 2 leads are attached, or where they should be attached. So if I just pick a random spot here, like right here, I have my 2 endpoints again. This top endpoint is connected all the way to the positive terminal, and this side endpoint is connected to the negative terminal. So I would place red lead here on the bottom and the black lead here on the side, and it would give me the voltage across that component. So that's for voltage. So I can measure that across any component. Now I can also use my ammeter as well to measure current. So let's say I want to measure the current across my components. So for example, let's say I want to measure the current going through the battery. The only thing, again, different about an ammeter is that this thing needs to be a part of my circuit. Again, I talked about how it's kind of like a turnstile, that it has to be within my circuit in order to measure the amount of current going through it. And you'll see that this thing has charge within it. All I got to do to use this is create an opening within my circuit, and then I'm going to place that ammeter within my circuit right there. Notice that once I have it connected properly, that it will then flow through and it'll give me my current. In this case, it would be the current supplied by the battery. Now again, what I can do here is I can move this throughout my circuit. So I'm just going to disconnect my ammeter from my circuit here, and let me reconnect it here to the wires. And now let's say I want to measure the current going through an individual component. So let's say I want to measure the current going through this bulb over here. If I want to measure the current going through this specific bulb, okay, we can look at the electron flow is flowing up through that bulb. So what I can do is make a disconnection at one of the 2 endpoints, okay? And you'll see as I do that, some of the circuit changes. But all I want to do then is add my ammeter into that gap that I created, and now you'll see that charge begins to flow through. And I can measure the current that's actually flowing through that part of the circuit. Okay, so this is a quick little tutorial on how I can measure the voltage and current through individual components of my circuit, and also know that there are some things that are also given to me. There is one variable that we cannot measure within this simulation and within, I guess, in general, and that is power. Power in terms of the wattage is something that we cannot measure, but is something that we can calculate. Okay, and we'll talk about that as we go through these next couple sections.